I'm Matthew Spremulli. Some of you might remember me from being formerly involved with the LAS directly. I'm joined today with Hlozan. We're from Autodesk Technology Centers. First off, just want to say thank you to Philip. Thank you to Sasha for inviting us. I hope what we can contribute to the LAS, which I'm always crazily impressed by all the interesting projects that happen, is a way to get engaged and in a way incubate some of the projects that we've seen. So if after what you've seen you like, we'd love to help you out with the projects that we see. So we'll kind of get started here where officially the technology centers are part of Autodesk Research. So some of you might have heard the name, some of you might have heard about like how this gets involved, and officially Autodesk Research is broken down into 3 main veins. So there's a science vein, and some of you might know this. One of the directors at our complex systems teams in Toronto also teaches at CETA in Denmark. That's Azam Khan. We have an industry futures team. Some of you might know David Benjamin from The Living in this group. And then the technology centers is the newest vein in Autodesk Research, and that's where you'll get to know Ellen and myself a little bit better. So in these are little samples and slides about what it is that we do. The science team tends to research things kind of a little bit further out, developing new technologies with papers, patents, and prototypes. The industry futures team tends to get involved directly with customers or academics on projects that will push technology forward. And then our group has a new mandate, which is what we call an open innovation model. So we have something called a residency program, and that is where we're not going to be able to research everything as a company. And so our mandate is to basically bring projects in and learn from those examples. So if after the presentation you want to learn more, you can visit our new website, and we'll also be around after the talk if you want to talk to us about how to get directly engaged.
Thanks. Hi, everybody. So I'm just going to give you kind of an overview of the mission of the technology centers and a few sample projects as well to hopefully whet your appetite. So really the intention of the technology centers is to explore the future of making and really take projects from the design phase through to the fabrication phase. So we obviously needed spaces in which to experiment with that. So our first mission is to speculate, validate, and test ideas about the future. And we do this through engaging with different residents and also sometimes customers. So there's a few examples here. You can see on the right-hand side, Harvard GIS, they came in and worked on an inflatable facade project. One of our customers, GM, worked on generative design for a particular seat bracket in their vehicles, and they were able to lightweight that and also take 4 parts down to 1 part using generative design. And then in the lower space, you'll see our research team working on some robotic welding. Our second mission is to kind of inform our product teams and business strategies. So this means that the residency program kind of creates a feedback loop for us so we can see what people are working on in Autodesk software and other softwares and where they'd like to push the boundaries, and then take that information back to teams that are developing these tools. And lastly, we create really interesting stories and engage with our community, and we do this in a few different ways, which I'll outline a little later on. But storytelling is also a major component of the technology centers. And globally, we have a few different sites. So you might already be familiar with Pier 9, which is located in San Francisco, the Boston Build Space, Toronto. And then we also have a last location in Europe that's kind of a dotted line to the rest of our group, and they're focused in a very specific area. So I'll give you a few more details on all the global sites. Boston is focused on industrialized construction. So this is looking at industrialized construction on-site and off-site and the use of robotics in relation to that. San Francisco is looking at configurable microfactories, so the scaling up and down of products, and also having flexible factory floors so that a different product line can be flexed and flipped really easily. Birmingham is the really interesting dotted line site that I mentioned. So they are working on very specific customer problems that are often very secret and very fascinating, but unfortunately we aren't able to share them a lot of the time. And they're doing that with particular customers that are deploying those solutions now. So they're pretty interesting, but pretty secret. And lastly is Toronto. So we're focusing on emerging technologies, smart and small solutions, and generative design in particular. So you'll see here an example from AU this past year, Autodesk University. This is a concept for a Mars lander. And just to give you kind of an overview of the program, we've had about, across all the sites, over 110 teams participate up until this point. And they're usually startups, academic groups, industry areas, or practice groups, just to kind of give you a sense of where we're getting all of these different residents from.
Cool, thanks. So to give you an idea about what kind of projects we incubate in the program, I'm going to work from a scale that's really large and then scale down to something really small and something that's kind of future thinking. So a team here in Toronto is called Transpod. They're looking at Hyperloop technologies, and they're basically interested in everything from the urban design and urban layout all the way down to sensors on the vehicles itself. So in the program right now, they're working on basically feedback loops of, let's say, stress sensors and how that might affect the fuselage of the actual vehicle itself. Another really interesting team based out of Boston is looking at robotic furniture. So this group called Ori is looking at how to transform or how to service really small micro condos and how you can essentially accommodate this with furniture. Really interesting thing here with the relation to the product team is that there was never in any of our software the ability to make moving or robotically programmed walls. So the Revit team was particularly challenged by this because they're like, well, we've never had that solution before or that challenge. So actually what's interesting for me with this group is that I've seen a lot of interactive, a lot of moving architectural components. I think having some projects in here that would trying to challenge those boundaries would be really interesting for some of our product teams to look at. Another team based out of Toronto is called Luxmia. They're looking at the application of generative design, so force, or rather form-following force in, being used for facades, in this case a space frame structure, and some furniture. MIT's Media Lab, the Mediated Matter Lab, the biomaterials. Actually, some of you might recognize Andrea. Andrea Ling used to work in the studio, and she's here working with our Boston team on essentially biomaterials, taking boiled down shrimp shells and turning it into a baseline chitin and printing structural panels. Another really interesting team out of Boston is called Apis Core. They are a startup 3D printing company for really large structures. There was actually a Mars Habitat Challenge that was issued last year, and they were one of the teams that actually won and moved to the next round by basically being able to take this render on the left and start to actually make it into reality on the right. We also support things in the community. So we helped out the Smart Geometry Conference that was here last May. One of the particular teams was called Mind Ex Machina, which basically looks at how to pair machine learning and robotics. In this case, we're playing around with how to control a collaborative robot with different experiments that students came up with, like drawing algorithms or things like manipulation of clay molds. Another really interesting team that we will be engaging with, hopefully by summertime, is a group from the UCL Bartlett. They call it the Research Cluster Unit 1, and they're looking at how to pair fluid dynamics and taking simulations and pairing it directly with robotic motion code. So I'll just let this run for a second. What's interesting here is the ability to pair simulation and form finding and then form making. I'm just gonna move on. So super briefly, I'll pass it over.
Yeah. So just to give you a sense of the local Toronto site, so you've got a better understanding of the program. The space that we have is we basically have a ground floor space where we do a lot of engagement and programming pieces, and we have a small lab specifically focused on generative design. We have a really interesting new printer in that space. It's an HP Fusion 580, so it uses nylon particles to print with. It's a beta, so we're testing it out, and our residents are actually able to help with the development of that technology. So we were working with CAD Micro on that, which is really cool. Aside from the engagement space and the small lab on the ground floor, we also have our bookended space, which is on our 3rd floor. That's where our resident studios are located. So just to give you a sense of that space, we have a visualization studio, a residency studio, and our fabrication workshop with all of our machinery there for the residents to work from. This is just a couple of images of what the space actually looks like, but you can come and visit us if you want to check it out. And so a little bit more about the residency program. What do we provide? So we give workspace, access to advanced fabrication machinery, connections to internal expertise and training, and a varying duration for residency. So minimum of, it can be as small as 4 weeks, it can go up to a year depending on the scope of the project and milestones. And there's no cost to participate. This is all funded by Autodesk. And just to give a sense of some more of the resources that are provided, there's connections back to the research team sitting here in Toronto, which is a really interesting group. Programming opportunities, we do a lot of programming for our residents, and there's opportunities to also program your own things, such as a symposium like this. And our whole network of sites. You get access to cross-tech center residencies, so if you come in at any of our sites, you can then kind of ping over to Boston, San Francisco, Toronto, any of them, to utilize other resources that are there. So there's lots of opportunities to kind of grow and shift around. Does anyone have any questions?
Yeah, it's quick. What's Autodesk's relationship to the intellectual property generated there?
So we don't take any IP. Everything that you bring into this space, you should be comfortable with being exposed to the other residents, but Autodesk doesn't take any ownership of IP.
Yeah, it's an IP, as was mentioned, IP neutral. So we can't protect you from each other as residents, and we don't have the same role with you. So no IP taken. Some people may come up with, let's say, vertical farming stuff or different printing technologies. It's all within your own domain. It's just to give us a glimpse of what the future will look like. And then if there's ways in which our technologies can participate in that, that's how we learn from it.
I have a rather direct question. As a UK-based architect, is there space in your Birmingham facility, or is it taken up by our automotive industry? Because Birmingham, UK is much more accessible than, say, is it Birmingham, Alabama?
Yeah. The Birmingham site doesn't yet have a residency program. So as was mentioned, there's a dotted line connection. But if there's a research project that is going to push a limit of something and probably challenge CAM specifically, that would be where that team could potentially get involved.
I have visited your Boston facility.
Cool.
Thank you so much.
Yeah.